This lecture is on finding volumes of prisms and cylinders, and here we see their formulas. For a prism, it's base area times height, b times h, where b is the base area, h is the height, and that will be in units cubed because it's a volume. A cylinder is like a prism but has a circular bottom, so therefore the base is a circle, so it's now pi r squared times height. So those are the two formulas we're going to be using to find volumes of prisms and cylinders. So first of all, going over to here, doing some cylinders. Those first, and then we'll get on to the prisms, which are generally a bit tougher. All right, so we have pi r squared times height for our volume. So that's going to be pi times 6 squared times 10, because half of 12 is 6 for our radius. And so this comes out to 360 pi meters cubed. You need a calculator to go any farther than that. Now this is an oblique cylinder. It's not straight up and down. However, the height is still just the the shortest distance from top to bottom, the one that makes a right angle. So that's your height. You don't have to worry about that angled distance. It doesn't make any difference. So the radius is now 4, since the diameter is 8. So it's going to be pi times 4 squared times 12, and that'll be in centimeters cubed. And again, you need a calculator for that. Okay, going on to prisms. A little bit more to the prism. It's a rectangular prism, so theoretically the base could be any opposite pair of sides. We'll say it's the bottom, and so the base is going to be equal to 5 times 8, which is 40. The height's 3, and so the volume is 40 times 3, or 120 inches cubed. Getting on to a triangular prism now. It's more challenging. Okay, the height is 17. To get the base area, let's draw this out. We need to cut it in half. It's an equilateral triangle, 6, 6, and 6. So this is 6. Half of 6 then is going to be 3. And this triangle's equilateral. When you cut it in half, it becomes 30, 60, 90. So to go from the 30 side to the 60 side, you have to multiply by a radical 3. So that's 3 rad 3. So the base area is going to be half times 6, because that's the base of the triangle, times the height, which is 3 radical 3, which is equal to 9 rad 3. So if you want the volume is going to be the base area, 9 rad 3, times the height, which is 17, and that'll be in inches cubed, so you need a calculator for that. Okay. Now, these are a little bit trickier. They're a little different shapes than you'd expect. The base is going to be this L-shaped thing here, so the height of all this is 2. So that's the height. We want to get the base. The way to get the base is to split this thing, either vertically or horizontally. I'll go horizontal. So this section here is going to be 3 times 6, so that's 18. Now it's 8 this distance, and this is 3, which makes this distance 5. So now this rectangle is 4 times 5, which will be 20. So your base is the sum of these two pieces, which is 38. So therefore the volume is base times height, which is 76 feet squared. 14, we do the same idea. The base is going to be from front to back, the height. So that's the height. Height is equal to 6. Now, we'll look at these two pieces. First, we've got the rectangle. The rectangle is 11 by 12, so that's 132. Then we've got to get the circle. There's a semicircle here, and so if this is 12, we know this is 12, which makes the radius 6. So it's half of a circle, so half times pi times 6 squared, which is equal to 18 pi. So what we do is for a base, that's going to be 18 pi plus 132. And to get the overall volume, we take the base, multiply it by the height, and overall that's going to be in inches cubed will be our volume. Okay, one more type of prism to look at. This will be a hexagonal prism. So you've got a hexagonal prism. It has a height of 20, and it's got an apothem of 2. So these are in feet, 20 feet and 2 feet. So we need to get the base area because we have the height. Volume's base times height. We have the height, it's 20, we need the base. So I look at a top view. Again, inside a hexagon, there's 12 of these triangles, so 360 over 12 makes this 30 degrees, which makes that 60. So to go from the side opposite the 60 to the side opposite the 30, you've got to divide by radical 3. So now, this one triangle is a half times base times height, and in the entire hexagon we have 12 of them. So our base is going to be 12 of these. So now we have a height of 20, and here's our base. We get out a calculator, multiply all of that together. So you need to know how to use your calculator pretty well, and it's going to be in feet cubed.